Hi, it's Mrs. Moret here with a little summary of Lesson 7, little recap. We also covered Lesson 8, but Lesson 8 was just some context to go along with this. So this is the Lesson 7 summary. You can find it in your textbook. And basically, the big idea for the lesson is that we need a way to determine the strength of a linear relationship. So when we're looking at scatter plots, we want to understand the strength of how well the points are connected. How correlated are they? Okay. And so scatter plots of data that are close to the line of best fit line are better modeled by the line than scatter plots of data that are further away from the line. So when you're thinking about using your line of best fit to maybe make some estimates, it gives you an idea of how accurate your estimate might be based on how close the data actually is to that line. The correlation coefficient is a convenient number that can be used to describe the strength and direction of a linear relationship. So we call this the correlation coefficient, and it's used to describe two things: the strength and direction of a linear relationship. So we use the letter R to stand for the correlation coefficient, and it can range in values from -1 to +1. All right, so you would never see an R value that's less than -1 or more than +1. It's finite within those two, the range of those two numbers. The sign of the correlation coefficient is the same as the sign of the slope for the best fit line. So if you look at these examples, the first three scatter plots here have negative correlation coefficients. And so when it says it's the same sign as the slope of the line of best fit. So I see this first one, this is going down. It has a negative slope because it's going down from left to right. Same with this one, but clearly the points don't line up as well. And that's why our correlation coefficient is getting closer to 0. Okay, so a correlation coefficient, or R value, of 0 would just be like there's no correlation between the data. It's all, the points are all over the place. This is also trending in a negative direction, just not, not as close to the line of best fit as the two before it. And then here, we start to see a positive R value. So while it's not a strong correlation, it's not a strong relationship because the points are still pretty scattered, it's now moving in a positive direction overall. And we're just going to see examples of increasing in the positive for the correlation coefficient. So a correlation coefficient of 0.02, that's like almost 0. So you can see they're all pretty spread all apart. However, here, those points are getting closer to the line. So increase is still a rather weak relationship, and we get stronger and then very strong as we go. So we can see, oh, those points appear to be a lot closer to that trend line or line of best fit. And then these points with a perfect R value of 1, they're just all lined up. All right. So an R value of -1 means it's a strong negative relationship. Strong but negative. Okay. All the way up to an R value of +1. Strong and positive. Okay, the other thing that we covered in class today was a little bit about, could you, use these words and come up with maybe some situations where that would apply to. So One thing that I was thinking of that we often see is how are height and shoe size related? Would you say that those values have a positive relationship or a negative relationship? Or sorry, correlation, positive correlation or a negative correlation? I would say that in general, as the height of a person increases, so does their shoe size. It's not going to be a perfect fit, probably be something like that. But I'd say it's probably a pretty strong relationship, okay, of increasing, positive and strong. And then another example that I saw was age and how far you could see at a distance. So we'll call that sight distance. And I saw some data and it looked like this. So as a person's age increases, their sight distance actually decreases. So it was a negative relationship, but it wasn't as strong as the previous example of height and shoe size. Okay, so something like that. All right, and that is what we covered in lesson 7 and 8, and I hope you find that helpful.